Hi everyone, quick walkthrough of section 6.5, linear inequalities. We're going to be taking a look at solving simple ones, a linear inequality by itself, and we're going to look at solving compound ones. First of all, a couple different things. If I write A less than B versus A less than or equal to B, those are two different things. And of course, this is A greater than B or A greater than or equal to B. So be careful that you're reading these correctly as you're working through values, because we're going to be talking about what are the solutions for inequalities. Basically, inequality is consisting of two or more expressions joined by one of those less than or greater than, or less than or greater than or equal to, signs. 3 is less than 5, x is less than 2, 3x minus 2 is greater than or equal to 5. To solve them and then post them on a number line, we're going to use an open circle to indicate a less than or greater than, and a closed circle to indicate less than or equal to, greater than or equal to. If you have a less than or greater than, your circle will be open because it cannot include that number. So for example, if we want to plot x is less than 2, you're going to have an open circle, and then the line is everything below that. Anything below 2, but not equal to 2. So that's why we can't color in the circle at the 2. If it's less than or equal to 2, meaning it could be equal to 2, notice the only change is that there's a closed circle. Now you're going to find a solution by trying to solve for x, and if the coefficient of x is negative, the inequality sign is going to reverse direction. For example, if we have the quantity negative 6x is less than 18 and we're going to solve it and graph it, the first thing we're going to do is divide both sides by negative x. When we do that, the inequality sign is going to change direction. That is a rule. And so we end up finding out that x is greater than negative 3. To graph this, because it's an open circle, because it's greater than, we're going to have an open circle with an arrow to the right. X is greater than negative 3, not equal to, greater than. By the way, you can always plug a number in here to check to see if it makes sense. For example, if I plugged in the number 2, is negative 6 times 2, which is negative 12, is that less than 18? Yes. But if I picked a number down here, for example, if I have my inequality sign going the wrong way, negative 6 times negative 6 would be positive 36, and that would not work. So that would tell you, if you shaded this area, that you were wrong. So you can always pick a point and plug it in to make sure. A compound inequality is when you put two of them together. For example, you have something like negative 3 is less than x is less than or equal to 2. It's kind of the same thing as me saying the price of this packet of chili powder is somewhere between $1 and $1.25, meaning somewhere in that range is where it goes. So negative 3 is less than x is less than or equal to 2. If we plotted this, this would be an open circle. This would be a closed circle. Let's see what that looks like. Okay, now the reason that this does not have a line is because it says x is an integer. That means it can only be the whole number of values plus or minus. You know, negative 2, negative 1, 0, 1, 2, 3, those are integers. If it was all real numbers, we would then have a line, an open circle from negative 3 to a closed circle at positive 2. So be careful, read those problems. Here's the real number version I just talked about. Open circle at negative 3, closed circle at positive 2. Now, how does this get applied to real life? A really common example are test grades. So let's assume that I had a student who wants to have an average greater than or equal to 80, of course. But, of course, they're going to be below 90 if they're going to be getting a B. Here are the first 4 test grades. What does that 5th one have to be in order to give him a B? Okay? So that means that the 98, the 76, the 86, and the 92, and some unknown test grade X have to be added up. Then we divide by 5, and that average is going to be greater than or equal to 80, but less than 90. So it looks something like 98 plus 76 plus 86 plus 92 plus x, all divided by 5, greater than or equal to 80, less than 90. Now you might say, how do I go about doing this? It's really important to break this into 2 equal parts. Now, the example that's shown here is that they go ahead and multiply both sides by 5. All the terms get multiplied by 5. So in the center here, we've kind of gotten rid of the denominator idea. This is fine. Or you can separate these out and you can say I have 2 problems. One is 80 is less than or equal to 352 plus x over 5. The other is 352 plus x over 5 is less than 90. And you can solve the 2 of them and bring it back together. Just be really careful that you check your work. Here again, if we're going to do it this way, this means we're going to subtract 352 from 400. We're also going to subtract 352 from 450, which is what they're doing here. And you find out that the score on this last test has to be greater than or equal to 48 and less than, 98. And if he had those, he would